I apologize for the last videos. At the end there, the screen went off. So I'm just going to continue with number 6, which is 10 to the log of 4. What does that equal to? And as I attempted to explain that this is a exponent form because 10 is the base. So if you were to rewrite this, this will mean log base 10, right? Because normally we write that base here, but we don't write when it's log base 10. Log of what will give you this exponent, and that's log 4. So that question mark must equal to 4. So this is equal to 4. Let's do a couple more. Same idea. I know these are tricky. ln of e to the 6, what does that equal to? Now remember, this is given to you in logarithm form, and that just means log base e. Remember, there's a base e here. So if I were to explain, to try to convert this back to exponent, e is my base, question mark is my exponent, and e to what power is going to give me e to the 6, right? So again, that question mark will equal to 6. So do you see a pattern here that a lot of times people think of this 10 here, and log base 10, people think of it as cancel each other. That gives you 4. Same thing with ln, natural log, it's a base e. That will cancel out with this e and gives you 6. I like you to understand why. So instead of trying to memorize it, because canceling is not really a very good terminology. Last one is e to the natural log of 20. What does that equal to? Now again, this is an exponential form, right? Because you have e to some power. If I were to write this as logarithm, remember normally you write log base e, right? But we don't write it that way. We just write natural log of question mark should give me natural log of 20. So that question mark must mean 20. So hopefully that explains to you about the worksheet. Now in basically what I want to write down is some properties of logarithm that you're going to be using for 11.4 as well as 11.5, and I'm going to just try to write them together and use it. So the first one is, now remember we are always talking about log that makes sense, obviously. So if you have log b of 1, that's always equal to 0. You know why? Because b to the 0 power is 1. Number 2, log base b of b will equal to 1. Why? Because b to the 1 power is b. So that's why these things are true. Number 3, if you have b to the log base b of x, that would just give you x. Again, I talked about it's kind of like these things cancel out each other, but really the reason is because that's the definition of log. If I write this as a log, that's what you will see. Number 4, log base b of b to the x, again same thing, same base will give you x. Okay, number 5 and number 6 are ones that you really need to be careful. The next 3, you want to use this in 11.5, which says this: if you have log base b and you have two things multiplied together inside parentheses before you take the log, that's the same as taking log of each one and add it together. Okay, so let's be careful about these though, because sometimes people want to use these rules incorrectly. Now the same thing for division, as you can imagine. Imagine that the multiplication and division rules often work opposite way, so this would be subtraction. Okay, so remember what I'm saying is that if you have multiplication of two things together before you want to take the log, that is the same as taking the log of each thing and then add them together. Number 3, if you have log base b of x and then you raise it to some kind of power, that's the same as having that power in front and then take the log of base b of x. So what you're going to be doing in 11.5 is to use 5, 6, 7 quite a bit, 5, 6, 7, to either expand logarithm or condense them as much as you can. So I'm just going to do a couple of examples for you, once again, to see if you understand these idea. So let's do an example where you're asked to expand logarithm expand the expression. That would sound a little better, I think. As much as you can. And remember these rules that I have 5, 6, 7, and I'll try to leave it up there so that you can see what I'm doing. Let's try to do one that such as log base b of 15x to the negative 1/2 y to the 1/3. Okay, so how do I use this? Now if you look at the rule number 5, by number 5, that's the same as log base b of 15, right? These are all multiplication, so that means I can take log of each thing and add them together. And now by rule number 7, right, sum of the exponent can be pulled into the front, so this part comes to the front now, minus 1/2 log base b of x, and then plus 1/3 log base b of y. Okay, hopefully that makes sense. Let's do another one that's a little harder. Let's do things like log base 3 of 1 over square root of x to the 4th y. Now, first of all, if you see radicals, the best thing to do is rewrite it as rational exponent. And remember that is x to the 4/2, which is second power, y to the 1/2, right? Because remember square root is 1/2 power. Let me just write it on the side here. Just make sure you remember that means this. And then that means 4 over 2, 1/2. Now, here you have 1 over, and that's in the denominator. Now, on one hand, you could say that you can use rule number 6, right, by 6, and say that's log base 3 of 1 minus log base 3 of x squared y to the 1/2, right? You could do that because that's a division. And then if you recall, let me go back to the top here, okay? Log of any base of 1 is equal to 0. So this part is equal to 0, right? This is 0. Now here, be careful because you have multiplication inside and you have a subtraction there. So if I were to expand that negative, okay, I want to be careful about this because this is together. That's log base 3 of x to the 2nd plus log base 3 of y to the 1/2. This is by number 5, rule number 5. And now you're going to take rule number 7 and say that that's equal to negative 2 log 3 of x plus 1/2 log base 3 of y. And then finally you can distribute the negative sign over, so negative 2 log base 3 of x minus 1/2 log base 3 of y. Okay, now I think that should be enough, well, for this part, but let's just do an example where they want you to write the expression as one single log. And that just means that you're going to go backward, right? You're going to be given something that's expanded and you want to condense them as much as you can. And again, just be careful about what rule to be used. So let's just do this example where I want you to rewrite 1/2 log of base b of 25 plus log base b of 3 minus log base b of x. And here the key thing is you want to follow order operation left to right. Yeah, so because when you have addition, subtraction, makes a big difference which way you do it. So let me take care of this guy first, right? Now remember that 1/2 power came from the exponent, so I can write it this way: 25 to the 1/2 power plus log base b of 3 minus log base b of x. Now this is just square root of 25, so that means it's really log base b of 5 plus log base b of 3 minus log base b of x. Left to right, these are two separate logs being added. That means that it was coming from multiplication before, if you recall. So I'm using the rules that you have above backward. And now that gets me to log base b of 15 minus log base b of x. And you have two logs separately being subtracted. That means that it really came from a division. And now you have it in one single log. I hope that helps and have a good weekend.